Hello, today we're going to learn about number patterns, and by the end of the day I want you to be able to recognize and complete number and picture patterns, and I want you to be able to write explicit formulas for sequences and use them to find term values. Alright, so if we want to find the next couple terms in this sequence, if I were watching this at home, what I would advise you to do is pause the video and try to work through these on your own, and then when you're done, hit play. Alright, hopefully you're done. And to go from 2 to 4, we're going to multiply by 2 each time. And so since we're multiplying by 2 each time, this becomes 32, and this becomes 64. This next value we get because if we add 2 and 5, we get 7. 5 and 7, we get 12. 7 and 12, we get 19. 12 and 19, we'll get 31. 19 and 31, and we'll get, what's that, 50. And this last one, we're going up by 4, going up by 4, going up by 4. So this would be 19 and 23. Now the goal today is not only to recognize these patterns, but to be able to find equations for them. So first we need to figure out the names of these. An arithmetic sequence is a linear sequence where it's going up by the same amount each time. So this one right here, we'll call that linear. Then there's geometric sequences, which we're multiplying each time, and then quadratic, which is the second common difference. So here's the notes on that. I kind of jumped the gun. Arithmetics, they have a common difference. That means you're adding the same amount each time or subtracting the same amount each time. Geometric, it has a common ratio, where that means you're multiplying by the same number. And multiplying or dividing. If you take like 4 times 1/2 to get 2, multiplying 1/2 is the same thing as dividing by 2. Now quadratic sequences we're going to just touch a little bit today, and then the next 2 days we're going to go a little bit deeper into. But this is when you have a common second difference in a function. Oops. Now this one is going to be exponential or geometric. Usually when they talk about the sequence, they say it's geometric, and just like down here, they call this arithmetic. But when it's a function, they call it linear. When this is a function, they call it exponential. All right, so this is an example of an arithmetic sequence. It's going up by 3 each time. This would be an geometric sequence. You're multiplying by 2 each time. Now this common difference deal, second common difference means if I'm going up by 3, 5, and 7, now there's going to be a difference in my differences that's going to be constant. Here's 2. Where in a linear, there's just going to be a common difference. Here you have to multiply by 2 each time to get to my next term. Now there are some sequences that we can recognize just by the pattern. We call this a Fibonacci sequence. If we add the first 2 terms to get the next term, add these 2 terms to get this term, and so on all the way up. Now when we have a sequence, a lot of times we write them in a table like this, where this is the term number. So the first term is 1, second term is 5, 9, 13, and so on. This formula right here, we call the explicit formula. And let's try to get that. Now, here we're going up by 4 each time. Going up by 4, going up by 4. Now, in our Algebra 1 course, we're told that 4, and since this is going up by 1, 4 over 1 is our slope. So our slope in our equation is what we're multiplying by the variable. So 4 times n. Now we need this other thing, which in algebra we would talk about that being the y-intercept. There's a couple different ways we can look at finding this. One way is since we have 4 times n, we can multiply 4 times 5 to get 20. What do I have to do to that number to get down to 17? Well, I can subtract 3 each time, and um, and hopefully that will give us our answers down here. So what's 4 times 4? 16. 16 minus 3 will give us that value. So it looks like 4n minus 3 works. Another way we can think about this is since the y-intercept is when our x value is 0. In this case, we're dealing with n's, but when this goes down to the 0th term, that just means we go back one term. So that would be 1 minus 4 would be negative 3. And that's how you get negative 3. Now to find the 20th term, we just plug 20 in for n. 4 times 20 is 80. 80 minus 3 is 77. All right, now try this one on your own. Pause the video and see how well you do. All right, hopefully you're done. We're going up by 2 each time, so my formula is going to be 2n. 2 times 3 is 6. I need to add 8 to that to get up to 14. Now to find the 20th term, 20 times 2 is 40. 40 plus 8 is 48. All right. Now, in this one, if I go up by 4, if I go up by 4 again, I don't get 18. So this isn't a common difference. Let's see if we can multiply. 2 times 3 is 6. 6 times 3 is 18. It looks like that's our deal here. We're multiplying by 3. So now it's geometric. Now, it helps a little bit if we make a table. Let's say 2, 6, 18, 54, 162. Now 2 is just 2. I can get 6 by doing 2 times 3. I can get 18 by doing 2 times 3 times 3. We're just multiplying by 3 each time to get our next term. Now let's look and see if we have a pattern. In our first term, so this is term 1, term 2, term 3, term 4, and term 5, there's not any 3. It's just going to be 2. In my second term, it's going to be 2 times 3. My third term is 2 times 3 squared. My fourth term is 2 times 3 to the third. My fifth term is 2 times 3. Oh, I forgot another 3 there. There should be 4 3's. All right. Now here it is. So now we need to look at the relationship between our term number and our exponent because everything else stays the same. There's 4, 3, 2, 1, and 3 to the 0 is just 1, so that's how that disappears. Well, 5 minus 1 will give me 4. 4 minus 1 will give me 3, and so on all the way up. So if I'm looking for my nth term, I would do 2 times 3 times one number less than n, which is n minus 1. So that's my formula, 2 times 3 to the n minus 1. Now I plug the 20 into this equation, 2 times 3 to the 20 minus 1, which is 19. And that should be a gigantic number. 3 to the 19th is really large, and if I multiply that by 2, that's even larger. I got a number like, all right, let's move on. Now, notice how this table doesn't go up by a constant difference, and you can't, if I multiply by 4, if I multiply by 4 again, I'd get to 48. So let's see if this has constant second differences. Here I go up by 9, here I go up by 13, here I go up by, is it 17? And then here I go up by 21. Now if I take the differences of the differences, it looks like I'll go up by 4, by 4, and by 4. So this tells us it's a quadratic sequence. We'll learn more about the formula tomorrow. Today, we're just going to learn how to recognize it. So if we look at this one, are we going up by the same amount each time? I think hopefully the answer you'll say is no. Are we multiplying by, is there anything we multiply 12 by to get to 35? Well, there is. 35 divided by 12 is 2.916 repeating, but if I multiply that again by 35, I don't get 70. So let's look for constant second differences. So this goes up by 23, then 35, and then 47, and then 59. So if I'm going up here, this is going to be going up by 12, 12, and 12. Since it's constant second differences, this is a quadratic sequence. All right, and if we look at this sequence, if it's written in this form, we'll just have to tell ourselves that that's one, first term, second term, third term, fourth term. Now, I like to write these vertically. Hopefully you can tell here to go, we're not adding or subtracting, because then it would, these would be off. Uh, you'd be multiplying by 1/10 to get to the next term. So my first term is 50. My next term is 50 times 1/10. My third term is 50 times 1/10 times 1/10. My fourth term is 50 times 1/10 times 1/10 times 1/10. And that's my first, second, third, fourth term. Notice how my fourth term, I have 3 1/10ths. My third term, I have 2 1/10ths. My second term, I have 1 1/10. So it's always one less 1/10 than the number of term. So my equation is going to be 50 times 1/10 to the n minus 1. So if I want to find the 10th term, what I have to do is put 10 minus 1, which is 9. And so I do 1/10 to the 9th power, and then I multiply that by 50. Now my calculator says something like 5e negative 8. What this means is 5 times 10 to the negative 8th. This is not a correct answer if you put that. So we have to know that this is the 10th term. So that's going to be 0.00000000. So 1, 2, 3, 4, 5, 6, 7. Let's see if I move it over 8. 1, 2, 3, 4, 5, 6, 7, 8. Wonderful. So this right here is the 10th term. And to denote the 10th term, we can write t sub 10. Some people use a sub 10 or u sub 10. Um, the letter here isn't as important as having some lowercase letter and then with a little 10 in subscript. All right, if we look at this, looks like we're going down by 2 each time, so that would be linear. So first term, second term, third term, fourth term, it's going to be a linear, and so I'm going to say that my slope is negative 2. Negative 2 times n, you can pick any of these numbers, negative 2n. So negative 2 times 1 is negative 2. What do I have to add to that to get 100? Hopefully you said 102. Or you can follow the sequence back, one more sequence, one more term to the 0th term, where that would be 102. Now if I want to find the 10th term, you do 10 times negative 2, which is negative 20. Negative 20 plus 102 would give us an a sub 10 to be 82. All right, here's your homework for tonight. Good luck.